Hi everyone. In this video, we are going to discuss about example of the transmission line. The given example is calculate the reflection coefficient and VSWR for a 50 ohm line terminated with first bit is matched load, second bit is short circuit, third bit is J150 ohm load, fourth bit is minus J150 load. So given that, coming to the solution, so given that the characteristic impedance Z0 is equal to 50 ohms and load impedance is terminated by first bit matched load and the second bit is terminated by short circuited and fourth bit is the load impedance is third bit the load impedance is transmission line is terminated with load impedance is J150 ohms and fourth bit the transmission line is terminated with load impedance minus J150 ohms. So calculate the reflection coefficient value and voltage standing wave ratio value. So coming to the solution, given that the load impedance the characteristic impedance Z0 is equal to 50 ohms and first bit solution line is terminated in matched load. End of the transmission line is terminated with matched load. So that is end of the line is terminated with matched load means that is load impedance ZR is equal to characteristic impedance. So given that what is the characteristic impedance Z0 is equal to 150 ohms, therefore the load impedance ZR is equal to 50 ohms. And calculate the reflection coefficient value and the standing wave ratio value. So we know that the reflection coefficient K is equal ZR minus Z0 by ZR plus Z0. So given that the characteristic impedance Z0 is equal to 50 ohms, now we are the transmission line in this bit. The transmission line is terminated with the matched load, that is ZR is equal to Z0. So therefore ZR is 50. 50 minus 50 divided by 50 plus 50. So 50 minus 50, 0 divided by 100. 0 divided by constant value is 0. The reflection coefficient K is equal to 0. Next calculate voltage standing wave ratio. VSWR is equal 1 plus magnitude of K divided by 1 minus magnitude of K. So K value is 0. 1 plus 0 by 1 minus 0 is equal to 1. Next, second bit solution. What is the second bit? End of the transmission line is terminated with short circuited. So line is terminated in short circuited, that is load impedance ZR is equal to 0. End of the transmission line is terminated with short circuited. There is no the load impedance ZR is equal to 0. And calculate the reflection coefficient value and standing wave ratio value. We know that reflection coefficient K is equal ZR minus Z0 by ZR plus Z0. Now here the load impedance ZR is equal to 0 minus 50, Z0 is 50 ohms by 0 plus 50 is equal minus 50 divided by 50 is equal to minus 1. The reflection coefficient K is equal to minus 1. So that is equal, and the magnitude of minus 1 is 1 and the phase angle is 180 degrees. And next calculate the voltage standing wave ratio. VSWR is equal 1 plus magnitude of K divided by 1 minus magnitude of K. So K value is minus 1. 1 magnitude of minus 1 by 1 minus of magnitude of minus 1. So that is equal 1 plus 1 by 1 minus 1, 0. 2 by 0 is infinity. Next third bit solution. And third bit, The end of the transmission line is terminated in load impedance ZR is equal to J50 ohms. So first calculate the reflection coefficient. K is equal ZR minus Z0, J50 ohms minus 50 by J50 ohms plus 50. So that is equal minus 50 plus J50 divided by 50 plus J50. So take the magnitude on both sides. So magnitude of magnitude of numerator term is 70.7 divided by magnitude of the denominator term is 70.7. The magnitude of the reflection coefficient is 1. And next calculate the voltage standing wave ratio. Vswr is equal 1 plus magnitude of K by 1 minus magnitude of K. 2 by 0 is infinity. Next, fourth bit solution. End of the transmission line is terminated in ZR is equal minus J50 ohms. The reflection coefficient K is equal ZR minus Z0 by ZR plus Z0 minus J50 minus 50 divided by minus J50 plus 50. So take the magnitude on both sides. So magnitude of LHS term is equal to magnitude of RHS term. So magnitude of RHS term is square root of minus 50 square plus minus 50 square divided by square root of 50 square plus minus 50 square. So numerator and denominator term is cancelled. We get magnitude of K is equal to 1. And voltage standing wave ratio VSWR is equal 1 plus magnitude of K by 1 minus magnitude of K. 2 divided by 0 is infinity.